Hello and welcome back to the WSMX programming training. In this lab recording, we are talking about lab number 4, and it is about creating specification files utilizing the device setup API. So we will learn about the device setup API and how to use it. We will create an AWG digitizer loopback setup, and for that we will um, start from this distortion AC device setup API test method, and there in the setup part we will specify the waveform to use, create an AWG and digitizer instrument setup, also set up the corresponding actions like the measure waveform and the source waveform, and we will create an operating sequence. And of course, we will execute the task, retrieve the results, and I think we also will compare it with the device or the distortion test method, where we use the standard approach with specifying a specification file and an operating sequence file. Okay, so as usual, we continue with the WSMX_lab program. As usual, please try to use the content insist as often as possible. Also use the other shortcuts as described at the end of this lab manual. And yeah, if you're using this in an offline session, please follow exactly the capitalization for the test suite names and the test descriptors, because this is what you will need to have um, a proper access to the offline result emulation, that you can check if everything went well. Okay, with that, let's come to task 4.1. Let me shift this lab manual here to the side, and we are here in my smart test session in the setup perspective. And in your lab files, you should already have predefined here in under the source folder in the distortion AC, you should have this distortion AC underscore DS API. And if you click into it, you will see here we have here actually the instantiation of our measurement object. We have a couple of um, variables. Also here we I think define the parametric test descriptors and so on. And um, no, the parametric test descriptors we have here, and here we have the limits for them. So, excuse me, I'm sorry. So, if you scroll down, the important part now is that we come here to the setup part of the test method. And as you can already see here, in the commands, uh, we give you here some kind of skeleton code where you then can use the device setup API to start with. And the first part is we are now here in the lab manual at point number 2. First, we uh, create the instance for the device setup API, and for that we just use device. Whoops, I have to click into here. Device setup, we could call it here DS as in the lab manual. Basically, you could choose any other name for that one here. And then we have the device, the device setup factory, and then we create an instance for it. And that's it. Okay, that is already the first part. Then we have here under point number 3, add a sine waveform to the device setup instance via the iSetup waveform sine interface. Set the frequency to the variable SRC frequency, which is already defined here. Yes, that one here, and the number of samples to 1024 and the sample rate to 100 megasamples per second. So for that, we go here and just type iSetup, and we probably have to keep on typing here to come to the waveform. Here we are. We need the sine wave. We call that stim as in the lab manual. Basically, you could have any other one. And then we have here the device setup, add waveform, sign, and then here we can give this waveform a name. And as in the lab manual, we call it sine wave SRC. Okay, so now we have our sine waveform, and we can then now use all those setter methods for it, like the set frequency. Here we go, and it's asking for a double, and you just like use control space once in this line, and then you keep typing, and the content assist will give you all those things here, and then you, for example, just click here on our SRC frequency, and that's it. And you can either now um, call again the stim object again and use the setter method for the samples. Here we go. That is 1024. And instead of typing another line here, we could actually just use that one and use also the setter method for the sample rate. Here we go. And that is 100 mega samples, whoops, per second. Okay, so sometimes for some readability, some people prefer something like this, and we could even go and do that one here. That is all the same. Okay, we save this one, and this is the setup of our waveform here, and using the device setup API. We can now go on to point number 4 in the lab manual, add an AWG instrument to the device setup instance, optionally enable the internal loopback, which is the cross connect. Yeah, let's do this. And for that we use the iSetup AWG interface. Control space already gave us that one. We call it AWG set, and we have also to refer to the device setup instance here, so DS, and then um, we have to add the AWG here. Yes, and we set this for the source signal here, since we're in the AWG. That's it. We can also set here the optional instrument config of the internal cross connect. For that we type AWG set and then set config and then optional internal cross connect. That is that within every um, module of the WScale MX card, you have an internal cross connect going directly from the AWG to the digitizer, and this is how you can enable it. If you set this, then usually the de-embedding and those things are usually ignored. Um, and also the that impedance settings should also be ignored for that one if you use the internal cross connect. I'm doing here now an offline session, as you can see here. So later we will access the um, offline result emulation data as given here. So for that, it doesn't really matter if you do this offline. If you're online, um, you can use it, but you could also use the external loopbacks provided by the E7010 uh, loopback board. Okay, so we set up the AWG instrument, and now we can continue to set up the source waveform action. For that we have source waveform. Here we go. We call this action source wave. You could basically take any other name which you think might fit and is descriptive. Descriptive. We have to refer to our AWG set um, here AWG instrument, and we just type in here source waveform, and we can still here give it a name, and we name it source action, and I think here we have to set this as a string. Here we go. Okay, or maybe we even have a string. Ah, yeah, okay. We don't have to do that one. That should work without. Yes. Okay, and then we can use all the setter functions or setter methods for this source waveform action, and we first set the waveform to it, set waveform, and here we already get the suggestion to use the stim. That is actually what we just set up here, right? Okay, and then we can go on and say, whoops, no, this is not what I wanted. We're gonna set the repeat count to 2 as we did in the previous one, and we can here set the amplitude as given in the lab manual. We also used the SRC. Oh, there was some content assist for that. Was it gone? SRC amplitude, here we go, and then we set the offset to 0, and we set the bandwidth, oops, to the SRC frequency, and here you can also use some operators, and here we go. Okay, so that is actually the setup of the source waveform action. With that, we can go on to the point number 6 in the lab manual, and that is to add a digitizer instrument to the device setup instance. For that, we can just go in here, and now instead of the I setup AWG, we use the I setup D digitizer. Here we go. Digitizer set as given in the lab manual. We have to refer again to our instance of the device setup API here, and then we just type in add digitizer, and the digitizing signal is suggested here. Very good. So again, we can use the internal loopbacks if we want to. Here we go. As I said, in the offline mode, it doesn't really matter. So, oops. So let's comment that out. And yeah, with that we can set up our measure waveform action. For that we have the I measure waveform. Here we go. We call it measure wave. Oops, is there? No, that should be fine. And the string name will be the digitizing action. Here we go. Did I have a... Where now I'm wondering what is the saying here? What is... Oh, actually we don't need this here. Sometimes you just have to save and then run it. Let's see if this will be resolved later. So let's just go on for the moment. measure wave, and then we use all those setter functions like the sample rate. Here we take 200 mega samples. And we set the samples as well. Here we go. Set expected. Why is this not working? Continue for a moment here. Okay, so we continue with the set low pass filter bandwidth. Here we have the SRC frequency times times 2. Still all fine. Do we have some amplitude here? Set expected does not really exist here. What else do we have? Okay, now I'm wondering why we don't have in the lab manual. It says we should use the set expected amplitude and then use the SRC amplitude. Um, let's see if this is another thing here. Measure wave set. Nope. Let me just check for the solution here. So that is the one from the solution. Okay, let's just maybe type it in. That should be fine. What is it telling us here? Okay. So we have here an I setup and it thinks that this corresponds to an I measure waveform of the DCVI instrument. That is not what we want. Do we have here some other? I'm sorry, so now I have to check again. I measure waveform. And that it's not really getting this as an iDigitizer. And here we want to have the measure waveform. Yes. The digitizer action. Okay, could be that it automatically imported that one here. Let's see what happens if I um, remove that one here and say that I want to have the eye measure waveform. We save that one. Ah, now finally it's gone. Ah, okay. So the thing was that at the beginning, somehow it automatically imported the interface for the iMesh waveform, but it did it for not a digitizer, but for the DCVI instrument, and this is why actually it marked that one as let's say wrong syntax, and also why we didn't have the content insist for the expected amplitude here, but now everything is fine. And with that we also set up the measure waveform. Just for some aesthetical reason I like to put it like this, and then of course we have to remove that one. Here we go, and the setup of the measure waveform action is done, and we can continue to creating the operating sequence. So just for reference, we are now here at bullet point 8 in the lab manual, and we are still here in the lab number 4, right? Whoops. So here we are. Okay. Let's create the operating sequence. For that, you basically just have to use the instance of the device setup API, and you start with parallel begin. That's all you need to start with the operating sequence. And here we have to use a lot of curly brackets, and then we can here um, follow the instructions as in the lab manual. First we gonna set parallel sync accuracy. That is set to this value here that we don't need. And then we have an action call for the source wave, um, and then we sequential begin. Then we have this wait call for the settle time. Do we have a settle time? Yes, we have here the settle time defined. That is why we put that one in here. And then we have another action call for the measure wave action, and then the whole sequential ends here. Now I'm curious if this is gonna work or if I made a mistake here. So the does not highlight any syntax error here. We'll see later. And now we go on and we have to assign basically the all those setups we created with the device setup API. We have to actually assign to our measurement objects, and this is what we do here. Oops, our eye measurement object here, and then we set setups, and then we use the instance of the device setup API above here. And with that, we um, completed task 1 of lab 4, and I will continue with task 2 in another video. So, hear you later. Bye bye.